These are crazy science experiments anyone can do at home, starting with a mini rocket.
This is 99% rubbing alcohol. Just a little bit, you just want to coat the sides. We drilled a hole in the middle of the bottle cap. This might break some things, but 3, 2, 1.
Oh my god, that's crazy.
This next experiment is called the fire tornado. I need you to rip this sponge into small little pieces and put it in this container. Don't need this no more. Now, this is a can of butane, which is lighter fluid. Light it.
We're adding a fencing to allow air to flow in a circular motion. And once we spin it, it creates a giant tornado effect.
There's a nice little tornado effect. And if we put a balloon over it,
Oh my god.
on to the next experiment.
Next, we have 2 aluminum can experiments. For the first one, we just need some drain cleaner.
Stuff you can buy at the hardware store. I'm gonna fill this up. Now, as my assistant, I need you to sand this Coke can. That's pretty good. Now we've sanded off all the labels. Now we need to open it. Ooh, we're gonna put this in. There we go. Instantly dissolving, that's crazy.
Up next is aluminum can versus gallium.
So the special thing about gallium is the fact that when it comes in contact with any aluminum surface, it will melt the aluminum. We can put the gallium on top. Why don't you spread it around? Safety touch.
We'll need some time for the melting process to happen, so we'll check back on both aluminum can experiments later in the video.
This next experiment needs to be done in the car. We'll just start with some Elmer's glue.
You're pouring glue in the car? Hafu, are you sure you're gonna be able to get that out?
We gotta trust science. Pour this into the cup, shake it up. Let's hope this works.
What if it goes into the engine?
Into the engine. All right, we have our beautiful slime. Now, this should clean our car. Clean the cup holder. Clean up some dust here. Clean up some dust. Now let's clean the steering wheel. Look at that, it's sucking everything up.
That's so gross.
Now we have a brand new car, completely cleaned with glue. This next experiment is the carbon sugar snake. This is our snake right here. It's just a mix of baking soda and sugar. What I need you to do is pour the rubbing alcohol. We want to pour this very concentrated. Ready? 1, 2, 3. Carbon sugar snake, come alive! So the sugar and the baking soda is now reacting with the fire.
As the mixture burns, the carbon dioxide gas is getting trapped inside, which is making the sugar come alive.
What are you gonna name your monster, Hafu?
Big Willie. I'm sorry, my man. Cool thing about this, you can actually touch it after. It feels like a croissant.
Yeah.
You can like peel it open, spread it open. We basically made bread. All right, on to the next experiment. This next experiment only involves a simple egg. This is what happens when you drop an egg normally. It breaks, as expected. But when you put an egg and soak it in vinegar for 2 days, this is what happens. Our egg is now see-through. And what happened here is the acid in the vinegar has actually broken down the hard parts of the eggshell, which became these bubbles. This is a before and this is a after. Now, what's left intact is the membrane inside, so the egg is actually bouncy. Look at this.
That's so cool.
Let's make a bet. Loser has to eat this. Make a bet on how high you think this egg can bounce without breaking. I'm gonna say here.
Okay.
You're gonna say higher than me? Okay, then I'm gonna say here. Okay, ready? We'll go here first.
You're eating the egg. I'm closer.
Oh, that's disgusting. That is actually disgusting.
You're eating the egg.
Honestly, it just tastes like pickles. Pretty cool science experiment. Very easy to do. Next. This is a normal lighter, but we're gonna turn it into a magic lighter. All right,
What does that mean?
we need the lights off. So what I'm gonna need you to do is just blow. Harder, blow harder.
Whoa.
Did you see that?
Yeah, that was really cool.
So when the flame blows out, there's actually leftover wax in the smoke. That's why when you add heat, it will relight on fire.
This next experiment is called fire suction. So I'm gonna need your help later. First, we're just gonna light this candle. Pour a little bit of water around I said a little bit. Place this on top. Place a glass over it, which is gonna create a suction once the fire dies out. And while we wait for the fire to die out, I'm gonna solve this Rubik's Cube so we can test the strength of this suction.
Ooh.
Yeah, it's working. Nice. Place a Rubik's Cube on top. Yeah. Okay.
1, 2, 3. Last one. Hurry up.
All right, there we go.
4.
What else can we place on top? Can we place this axe can on top? Can we place this goggle on top? Can we place, oh, okay. Now we can weigh out everything on top, and that's a total of 1,161 grams. The power of this tiny little candle. Next experiment. This next experiment is called water suction.
Should I be concerned?
Just a little. You're gonna put some food coloring in this water, just so it's visible. Swirl it around. And now, we're gonna make me 10 times more attractive. This is Axe body spray. Every high school man's dream. Spray me. How does it smell?
No.
On the can of Axe body spray, it has a fire emoji.
Whoa. That's
Kind of like a
cool.
flamethrower. But that's not our trick. Our trick is we're gonna use this inside of the bottle, just a little bit. All this water will instantly go into the bottle once I light this.
Whoa.
And that's water suction. Is fire suction cooler or water suction?
Water suction.
When we're sucking, it needs to be a little wet for it to be fun, right?
Yeah, especially when it's red.
Next experiment.
So now we're gonna make a dry ice bubble maker, all right? When we put dry ice in water, starts a reaction. Look at that.
That looks pretty cool.
We're gonna now screw on the caps and then stick the tube in, not too far though, just a little bit. And we'll just tape it. Look at that, dry ice bubble. Woo! It bounces.
We're dipping the tube into a dish soap solution. The dry ice smoke gets trapped in the dish soap, which starts to form a bubble. And our goal is to make the biggest bubble we can.
That's the
Look
process.
how big this is. Look how big this is. Oh!
Next, we have a chemistry experiment. I'm gonna show you how to make elephant toothpaste with just grocery store ingredients. All you need is some yeast, hydrogen peroxide, which is for wounds, an empty bottle, dish soap, and food coloring of your choice. So first we just pour the hydrogen peroxide in here. Let's add a little bit of dish soap. And I'm gonna add a dash of red food coloring to signify love. We have our yeast. Let's add it to some warm water. The yeast would be the catalyst that will start this chemical reaction. Now, this is the last step to our experiment. We add the catalyst into the solution that we made. Whoa! Hopefully you don't explode this fast on your first date.
All right, it's been over an hour. Let's check back on our aluminum can experiments. Got the drain cleaner one right here. Let's pull this one first. Oh,
Good.
look at that. It's
Wow.
smoking. So the drain cleaner has melted away all the aluminum, and the only thing that's left is a plastic wrap inside. It's a sponging can. That's so cool. This is a gallium can. We left it there for a couple hours. I noticed some interesting textures. Let's see what happens. So as you can see, this can has become destroyed. Let's just give it a little squish test. Wow. Let's try poking through with our fingers. Oh my God. We can basically crumple this can. It's like an aluminum croissant. Next, we have two tiny air guns. So how this works is literally just a cup and a balloon attached to the back end. Do you feel that?
Yeah.
To see if it actually is working, let's light it on fire.
Why does every experiment involve fire here?
Because fire is cool. Try blowing this up. There we go. That's pretty cool, right?
Yeah.
Now, let's step it up a little bit.
That's huge. What are we blowing with that?
Your mom. So what we can do is actually we can just burn a little paper and it will become a smoke cannon. You can just put the paper inside Our smoke cannon is now loaded with smoke. We can aim and fire it. So we got bottles set up over there. Here's the challenge. Whoever knocks down the most number of bottles wins. And the loser has to drink lemon juice.
Okay.
We get 3 shots each, okay? Okay, I'll go first. Oh, you see that? Need to aim it a little lower. Okay.
Oh, 2 down.
Let's see if you can
Okay.
beat that. There we go. Oh!
Oh my gosh, come on.
Got one last shot. Oh my goodness.
Did it.
Shoot me, shoot me. Oh!
Whoa.
Oh!
Loser has to drink lemonade.
This is lemon juice, it's not lemonade.
This is so sour. Holy crap.
So this is the world's most powerful laser pointer. We need a different type of eye protection for this one. We need sunglasses. Mine are actually red because it cancels out the blue light from the laser. Let's test it on a balloon. How many balloons do you think this laser will burn through? 3? I think it will burn through all these balloons. So I've even set up a match at the end to see if it can light that on fire. Okay, ready?
Yep. Let's see it.
Oh! That was fast. 3,
Oh.
4,
Oh, it kept going.
5,
Oh my god.
6, 7. Let me go a little closer. Oh! This laser is cool. And it was only like 70 bucks.
Only?
This next experiment only requires hand sanitizer. I'm sure you have some left over, but don't try this at home. Extremely dangerous. It's called fire hand. And in order for you to see this, we need to turn the lights off. All right, that's better. First, we're gonna squeeze the hand sani onto our surface here. Spread it around, and then wet our hands so we don't burn ourselves. And then, last step, a little bit more of hand sanitizer on our hand. Let's watch the magic happen. On to the next experiment. All right, now it's time for the final experiment. We're gonna use everything we learned and combine it into a butane rocket.
What does that even mean?
A butane rocket. So, butane, when it's combined with Coke, it will react at such a fast pace that it becomes rocket fuel. As my assistant, I need you to hold this.
Yep.
Wait, let me think about this. I don't want to blow you up. So what I'm doing is I'm just letting the butane out into the Coke bottle. We now have butane in this container. It is kind of smoking outside, as you can see. Can you see that? We're gonna see how this goes. 1, 2, 3. Okay, we didn't have enough butane in there. Okay, so what we're gonna do instead, we're first gonna fill up this Coke bottle with only butane, and then we're gonna pour it into this Coke bottle. On top, we got a butane layer, and then on the bottom, we got a Coke layer. Once I flip this over, that's when the reaction will start. Butane rocket, 1, 2, 3.
Whoa!
Now we gotta do a bigger version of that.
That was
and on fire.
crazy. On fire?
We only have 1 shot for this. We used 3 cans of butane, and this is a big Coke bottle. And guys, again, do not try this at home. Now the butane is going inside the Coke bottle. I need you to step back. You're gonna light this on fire. You ready?
Oh my god!
This is flaming butane rocket. On 3, 2, 1.
Oh my god! Where did it go?
How do you feel?
That was scary.
The science rocks!
This is a nitrogen rocket.
We're just gonna pour the liquid nitrogen into the Coke bottle. And once I cap this, the pressure is gonna start building. Oh shoot! Yeah. Oh my gosh, that's so tall. I didn't know it was chill like that.
This is a whoosh bottle experiment, and you can easily do it at home.
All you need is some big jugulars, rubbing alcohol, and a lighter. Pour in your alcohol. What we want to do is just swoosh it around until it fully coats a jug. And we can pour out the rest. The alcohol evaporates and mixes with the air inside, so now it's extremely flammable. Oh.
Now that's a whoosh!
These are secret spy glasses, and it's really easy to make. Grab an old LCD screen and cut off the top polarizing layer. Then there will be left a nasty layer of glue that you need to scrape off. Now when you turn on the monitor, all you'll see is white. To reveal the image, simply place a polarizing layer over the screen. Now attach this polarizing layer to some frames and you have secret spy glasses. This is a homemade flamethrower made with cinnamon powder. Cinnamon powder contains a lot of oil, making it water resistant.
That means if we dip our finger into the water, it should not get wet.
If we just pour some into the squeeze bottle here, that's gonna be our flamethrower. So if we just take a lighter and squeeze our cinnamon onto it, we should have a flamethrower. It's go time. Oh, yeah. You can splice DNA at home, and it's really easy to do. First, grab a big, blackened, girthy banana. I need to get this banana DNA so I can grow a new one because mine is too small. Put the bits into a Ziploc bag and beat your banana until it's smooth. We need to make the extraction liquid by mixing warm water, salt, and dish soap together. Now, pour your extraction liquid into the banana sack and let it sit for 10 minutes. Next, use a funnel and a coffee filter to filter out your creamy banana juice. Now we can add rubbing alcohol to separate out the DNA. You'll start to see 3 different layers. At the bottom is a banana, the middle is the alcohol, and the cloudy white stuff at the top is your DNA. Now you can pick this up, look at it, play with it. Now I can grow a real banana.
What happens if you pour nitrogen in water?
We have our liquid nitrogen here, negative 320 degrees. Anything it touches, it will instantly freeze. Oh, this is a broccoli. Oh, this is a bread. Yummy. We are now pouring the liquid nitrogen into the pool. This will create a massive smoke effect. Oh. The liquid nitrogen is sitting on top of the water. The water is actually considered hot to liquid nitrogen. So it's causing the liquid nitrogen to instantly boil and then turn into vapor. That looks so cool. This is a self-exploding balloon. To make it, all you need is Ziploc bag, baking soda, pure citric acid, and vinegar. In the bigger bag, add a 1-to-1 mix of baking soda and citric acid. Shake it up a little bit. In the smaller bag, add vinegar. And before you seal it up, add some air. Now place the smaller bag into the bigger bag. Now when I whack the smaller bag, the vinegar is gonna mix with the citric acid and baking soda, causing a huge chemical reaction. It's go time! Oh! Oh my gosh, that's gonna be insane. Oh, it busted.
This professor risked his life to prove a scientific theory. But what is it?
So I've recreated the experiment at home to test if it's real.
It's called the conservation of mechanical energy, meaning
If I let go and give it a push, the weight should come back further than where it started. Now that's pretty dangerous. But if I don't add an outside force like a push, then the kinetic energy should stay the same. It will come back but not have enough energy to go past the initial starting point. And I'm willing to bet my life on science. If this goes wrong, I'll probably end up with a few broken teeth. It's go time! Oh, science!
this is a magnetic foil ball, and it's really easy to make. Steal a large piece of aluminum from your mom's drawer. Then wave a magnet over dirt to get iron filings, which you will use to fill the center of the ball. Scrunch up your aluminum ball. Roll it up. Beat your ball hard until it's round and smooth. And use some sandpaper to smooth it out. Now you have a ball of steel. Let's see how magnetic it really is. You can use some regular magnets to guide it around.
Now let's try a super magnet. It's go time.
Now it moves around even faster. And you can play catch.
Got it!
How are these liquids floating on each other and not mixing? Let's recreate this experiment and find out.
At the bottom, we have maple syrup because I'm Canadian. In the middle, we'll have water. And at the top, we'll add oil.
No matter what, these liquids won't mix because they have different densities.
To show you the different densities, if we drop a nut, it will sink all the way to the bottom because it's heavier than oil, water, and syrup. But if we drop a grape, it will stay in the middle layer because it's less dense than syrup. And if we drop a bottle cap, drop, it will float on top of the water. And lastly, if we drop a sponge, it will float right on top because it's the least dense. And after all that, we can see the difference in density between all the liquids and the objects.
This is a real-life laser beam. While it looks like something out of Star Wars, it's really easy to simulate.
So here's the setup. We have a 5 milliwatt laser. In front of it is a fan that we're able to control the speed of. And in order to see everything properly, we had to fog up the place with a fog machine. Believe it or not, this is not special effects. It's all done in camera, only because we have a perfect match between the shutter speed, the laser, and the fan speed. So now it looks like the laser beam is going through my hand. This chemical reaction looks like magic. There's no editing trick. It's purely a kinetic reaction. To make it at home, first pour 120 milliliters of water into a container. Crush your vitamin C into a fine powder. Then measure out 500 milligrams and mix it with your water. Once it's all mixed, add 12 milliliters of iodine. And you can instantly see the iodine color instantly disappear. We'll leave this aside and start mixing our second solution. Add 40 milliliters of boiling water and add 200 milligrams of cornstarch and mix it well. Now mix in another 100 milliliters of hydrogen peroxide. By now, you should be feeling like Walter White because both of our solutions are done. Now we just have to mix the two liquids back and forth, and then they should instantly change colors after a while. Whoa! This is a homemade lava lamp. All you need is baking soda, vinegar, vegetable oil, food coloring, a tall cup, and a flashlight. First, feed thick spoons of baking soda into the cup. This is what will power our lamp. Next step is to oil up and fill up the entire cup with oil. Now in a separate glass, mix vinegar with some food coloring. Once we pour in our vinegar, it should start to power the lava lamp. This works because the vinegar is reacting with baking soda, which is making the liquid bubble and circulate. Ooh, so cute. This is a homemade smoke cannon. Smoke rings look cool, but smoking is bad. So here's how to blow smoke rings safely. First, cut a water bottle near the top, since it's more solid than the squishy bottom. Next, cut off the top of a balloon. Stretch her out real good. So now you can easily wrap it around the bottle. To make smoke, put a few matches on a piece of foil and roll it up with a pencil. Fold the top of the foil and take the pencil out. So when you light the tip, smoke can only escape from one side. Our bottle is now filled with smoke. Tap the back to make smoke rings.
This is instant snow. To make it,
All you need is distilled water and sodium polyacrylate, which is found in diapers. This material can absorb 800 times its own weight in liquid. And when you add some water, it forms a snow-like structure. Now let's try it on a bigger scale with more sodium polyacrylate. Oh my gosh! It's starting to look a lot like Christmas. I feel like Elsa.
what happens if you pour lava in water? Minecraft tells me it will make an unbreakable material called obsidian. So to test if that's true, we have to make some lava. First, heat up the furnace. Then we add the rocks and let it heat up until it turns bright orange and it will start melting.
Alright, our lava is melted. Now let's get it into the pool. Oh my gosh, that looks so cool! Whoa! Let's dump the whole thing in.
It's boiling and turning into steam instantly.
Now we just have to dive down there and retrieve our obsidian. So we retrieved all of our rocks. The texture here is super interesting. You can basically break it apart just with your fingers. That means Minecraft is alive. We're making a magic lighter that ignites a floating flame. Take a normal pen and dip the ink onto the tip of a lighter and watch the magic happen. Oh, yeah, the flame is floating. This works because normally when a lighter burns, it emits blue light like this. But when ink is burned, it's emitting ultraviolet light, which we can't see with our human eyes. Moving on to level 100. Did you know that we can bend light using water? So if we shoot the laser pointer through normal water, it's just a straight line. Nothing really interesting happens. But when you shoot lasers through different liquids, it can alter the behaviors. Let's try the salt water first. So now the bottom has a layer of salt water. Let's see what happens when we shine our laser through it. As you can see, with normal water, the laser just goes straight, but as we move down lower and lower, now we're entering the saltwater zone. The laser is bending at the tip. This is happening because the salt water is more dense, which means the light is traveling a little slower. Let's see what happens if we pour oil inside. So now that our oil has settled, we now have a smooth surface at the bottom here, and it's creating a divide between
the oil and the water. Let's turn off the lights. When you shine the laser through oil, look at what happens. It creates a laser reflection. This is because the oil has a smooth surface at the top and the bottom. It kind of acts like a mirror for the laser. This next experiment is one of the coolest but also easiest experiments to do. We're gonna make instant ice. Here we just have a normal bottle of Fiji water, but watch what happens when I slam it. Ice starts to form. You see that? That is so cool. Because this is a bottle of super cooled water. I tried a lot of different methods to make these super cooled waters, and this is the best one I found. So first, you take your Fiji waters and you just put them in the fridge and leave them in the fridge for 3 hours. So after the waters have been chilling for a couple hours in the fridge, now we're gonna move it into the freezer. And now we need to set a timer for 2 hours. When you're taking it out, be very careful not to shake the bottle. Now you're ready for some experiments. Now let's test the instant ice with some frozen fruit. So this will produce a really cool effect. This is a whole bottle of super cooled water. We're just gonna pour it in here. Ooh, that is cold, that is cold.
I'm just blow drying it so it's not foggy, so you can see it better. Let's start with the strawberry. Oh, oh my goodness. Oh, that is so cool. It's like an instant ice lollipop.
So we super cooled the water to below freezing temperature, but why was it still liquid? Because for water to turn into ice, it needs particles to form ice crystals around. Normally, it'll be the chemicals or dust in your tap water. But purified water doesn't have those chemicals, so the crystallization process can't start. That's why when you tap it, it starts the process. Or if you pour the super cool water onto the ice, it will start forming because the ice is starting the crystallization process.
That is so cool. Wow.
Whew. That is cold, but that's almost like a magic trick. For this experiment, we're gonna make slime come to life with magnets. So to make the slime, just take a bottle of Elmer's glue and let's squirt it into the bowl and just add equal parts water. And now we mix until it's fully dissolved. Next, we're gonna take a 1/4 teaspoon of borax and we're gonna dissolve it into a 1/2 cup of water. Slowly pour in our borax solution into the glue. Now we just need to pour it out and knead it like bread. That is a weird texture. Now we got the slime, we're gonna make it magnetic. These are iron filings. You can be pretty generous here. The more you put in, the more magnetic it will be. Our slime is ready. To make our slime come alive, we just need this, a strong magnet. And later, we're gonna test it with this super magnet and see what happens.
Oh, yo! Oh my God, do you see that?
What would happen if I just threw this whole thing in?
Oh,
Yo!
yo, this is cool.
Now let's try it with our big boy super magnet. Let's see.
Oh, oi, 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 oi. It looks like a Pokemon, to be honest.
Now let's put the slime onto the super magnet and see what happens.
Whoa.
It just like immediately cleans on. For this experiment, we're gonna make a magnetic motor using a simple AA battery, magnets, and some copper wire. The first step is stick the magnet to the bottom of the battery. We're gonna make this copper wire spin with the motor, so we wanna make a shape. The easiest shape we can make is like a McDonald's M. Here we go! Spin! Why is it not spinning? Just give it a little head start. Whoa! Yo! That's spinning really well. These coils are moving because the magnets that we placed here are creating a magnetic field. Lastly, this is my favorite shape. I love you all. And this is for you. Spin! You can make any shape with the coil as long as it's perfectly balanced. Now let's spin into the next experiment. For our next experiment, we're gonna make this egg explode with the help of some science. First off, all you gotta do is just peel it. Nice and simple there. And now, get a plate and a small bowl or a cover. We need the cover in case it explodes on us. We don't want to clean up the mess. Pop it in there. In my testing, I found that 30 to 40 seconds seems to be about the sweet spot. Not on my watch. I'll give you a quick demonstration. 3, 2, 1. Ooh! We're now gonna play a game of egg roulette with my roommate Doug. You ready?
I'm ready.
Rock, paper, scissors on who goes first.
All right, ready?
Rock, paper, scissors, shoot.
I got him. Okay, I'm strategically gonna go for this one. Oh, I don't like that. I don't like that.
All right, that one's normal.
Okay. Nothing.
Okay, I'm gonna go for this one. Okay, that was a normal.
You
egg
didn't even
too.
stand back on that one. You stood back on mine like you know which ones they are.
Oh, it's all random, man. Oh crap.
Okay.
All right. All right, let's clear the board. We're now down to the last two. Make your choice wisely.
The last two nuts. Wow, look at that. Jeez.
Yeah, because there was like a buildup of steam inside and the white parts trap the steam in.
Oh.
So when you cut into it, it just all explodes out. With this next experiment, we're gonna be able to alter one of the primary elements, fire. So normally, when you light a fire, it's orange. But with these ingredients right here, we're able to change the color of the flame. Remember, never go in raw, always wear protection. So we got 5 tins here, and each one of them we're gonna fill up with our fuel, methanol. All right, as you can see, methanol just lights as a blue flame. The second tin, let's add some boric acid in there. Oh yeah, baby. Have you ever seen such a pretty flame? It's like a video game flame. And this is completely safe to burn. This is so cool. And then our next flame is gonna be purple with the salt substitute. Let's add that in there. Look at that. It's a little hard to tell the difference between purple and blue, but that's definitely purple in real life. You know, our next container, we're just gonna add normal table salt, which will make it yellow. Look at that. That is incredible. Lastly, we got the lithium. Oh, look at that. It instantly reacts. Whoa! That is a very vibrant red color. Like, I cannot believe this exists in real life.
We can also combine these colored flames with our previous fire hands experiment to make colored flames you can hold.
Now we're gonna combine all these colors and make a rainbow colored flame tornado. So this is a mesh trash can glued to a Lazy Susan. As it spins, air catches inside, propelling the flame upwards, making a giant tornado. It's go time. Oh, yeah, that is amazing. Look at that. This almost doesn't even look real. Whoa! Let's blast off into the next experiment. Would you believe me if I told you I could make a balloon invincible? This is just a regular balloon. And this is a thumbtack. And let's place it down. Do you think this will pop? Ah! I mean, oh, yeah. Man, that's kind of to be expected, right? But what if we added more thumbtacks? You would think this would probably pop instantly, right? Let's find out. Nobody's better at blowing than me. Let's see. Look at that, it's not popping. And not just that, we can even add some weight to it. One gold play button weighs about 5 pounds, and the balloon is perfectly supporting this. So let's add more weight. Adding a second play button, this is 10 pounds. Look, I'm not even touching it. I'm just helping it balance. This balloon has now become invincible. I can even like bounce it, give it a little jiggle, and it's still not popping. The explanation for this is actually quite simple. This is because when there's only just one pin, all the pressure is focused on that singular point. But when we place a bunch of pins underneath, the pressure is distributed all across these 100 pins, and each one of them doesn't have enough pressure to pop the balloon. This is very counterintuitive, and people use the same law of physics to walk on nails. Let's add more weight. I'll just use my third hand, hold it in place. There we go. Okay, let go. Yo, look at that. The balloon is like fully. Oh, I guess we found the limit. On to the next experiment. This next experiment can be potentially fatal if done wrong. So do not try this at home. I am gonna attempt the dangerous art of fire breathing without any previous experience. So when you normally see professional fire breathers, they train for years because they need to learn to not swallow the toxic lamp oil that they use, and so they don't burn their face off. But I'm gonna attempt the same trick a little differently. So all we need is some powdered sugar. Powdered sugar, when you burn it normally, it kind of just melts like a marshmallow. It doesn't really catch on fire. This is because powdered sugar is so fine that there's no room for oxygen to go in and catch on fire. But if we take the powdered sugar, put it in our mouth, and spit it out onto a burning flame, something different will happen. Ooh. And with the power of science, we just successfully attempted fire breathing with no previous experience. Let's go bigger. That was freaking cool, man. For our final experiment, we're gonna make fireworks using these two things: 9-volt battery and steel wool. Normally, you wouldn't think this stuff is flammable, but watch what happens when I touch them together. Look at that. It just instantly ignites. When the battery touches the steel wool, it completes the electric circuit. But steel wool isn't a great conductor, so it generates a lot of resistance. And resistance generates heat. When there's enough heat, fire. And because steel wool is made up of such fine strands, it has a lot of surface area to catch oxygen, which makes it ignite even faster. And when we tie it to an end of a rope and swing it around, that's when we get fireworks. Now it's dark and we're in a park. It's time to set off some fireworks. Ready? Woo! Woo! That is hot, bro. Woohoo! This is so cool, man. Now, that was incredibly cool, and it's such a cheap thing to make as well. But there's something even cooler we can do, and it's a camera trick. So if you set your camera to a setting called long exposure, you can recreate the Doctor Strange portal. We're gonna become Doctor Strange! Goodbye! And now we just need to bring it into Photoshop and let the magic happen. Here's the final result.
What you're seeing shouldn't be possible. These coins balance like they're defying gravity. No matter how hard you tap, they won't fall.
It looks impossible because it is. There's actually a powerful magnet at the top and at the bottom. And the invisible magnetic force is what holds these coins together. This next trick lets you bring your drawings to life. Just like that Doodle Bob episode in SpongeBob. Here is our magic marker. And with it, I'm gonna draw a portrait of myself onto this plate. Here's my big head because I have high IQ. And then a big, girthy pair of legs. And now, if we pour the water on top, we should see our drawing come to life. Oh, our stick man is starting to come alive. The drawing is able to float because the marker ink doesn't stick very well to a plate. So when you add water, it goes under the ink and lifts it up to the surface. And the water tension keeps the drawing floating and moving around. Just make sure there are no gaps or your drawing will be destroyed. If you think this is cool, wait until you see the next experiment. This liquid might look harmless, but watch what happens when I drop in this cup. Our cup completely melted, but what's gonna do to my finger? Ah! Just kidding. This is actually completely safe to touch because it's acetone, or some may call it nail polish remover. So acetone is really good at breaking down plastics. And styrofoam is just plastic filled with air. So the moment acetone touches the plastic, starts breaking everything apart. Oh, that looks so cool. As dangerous as this science experiment looks, the ones that are coming up next are even crazy. What happens if you poke a bag of water with a pencil? It leaks. But what if I shove it all the way through? Oh, no leaks. Let's try another one. And as long as you're careful, you can just keep shoving pencils in. How is this possible? It's because a quick poke leaves an open hole for the water to escape. But when you push the pencil all the way through, the plastic stretches tight around the pencils and seals the hole shut. And here's the fun part. You can just keep adding more pencils. All right, a bit of a skill issue here. Okay, on to the next experiment. Did you know that oranges can be toxic to balloons? But if they can do that, why is it still safe to eat? It's all because of a chemical in orange peels called limonene. And just like acetone, limonene melts through plastics and latex. That's why the balloon pops. But you don't have to worry since you're not made of rubber. You just made it out of one. And here's the wild part. Limonene is a flammable oil. So that means if you light a flame, you can use your orange peel as a flamethrower. Oh, woo! That was a big one. Now you can impress your friends. Aren't you glad you learned this trick? Let's move on to the next one. This is a normal ruler. When I put it on the table and hit it, nothing interesting happens. But when I place the ruler down with a piece of paper on top, watch what happens. Oh, the ruler is now trapped. And no matter how hard I slap, the paper won't lift. I can even drop an apple on it. Or a basketball. It works all because of physics. When you hit the ruler fast, the air underneath the paper doesn't have enough time to escape, so the pressure holds the paper down tight. But if you tap the ruler slowly, air has enough time to slip underneath and lift up the paper. But if you try the same experiment with a wooden ruler and a bigger piece of paper, watch what happens. And that is the strength of science. Now let's break into the next experiment. This next experiment turns a leaf into a tiny speedboat. All we need is just a leaf. And now just take a regular pen and dip some ink at the end of the leaf. And now place it in the water and watch it right away. It's go time! Oh, yo! That's crazy! That was so fast! Yo, this is literally a speedboat. It moves and it leaves a trail of color right behind. It works because ink has tiny oils that spread fast on water. This lowers the water tension behind the leaf, but the tension is still strong at the front, so it pulls the leaf forward like a tiny invisible motor. And the more ink you put, the faster it goes. Now let's drift into the next experiment. This is my bed of nails that I use for massage sometimes. And this is an invincible balloon. No matter how hard I press on the nails, the balloon's not popping. But the trick is actually in the nails. Because if I just have a single nail, the balloon pops instantly. So what's happening here? It's all about pressure distribution. Placing the balloon on one nail puts all the pressure on a single spot, stressing the rubber until it pops. But placing the balloon on this nail bed distributes the pressure across multiple points of contact, so no single nail has enough pressure to poke through the balloon. And this is the exact trick that performers use to walk across nails without getting hurt. And now let's walk into the next experiment. This metal turns into liquid when you touch it. It's called gallium, and it's completely safe to touch, but it melts through any metal it touches. I left it on this soda can for a couple hours. Now the gallium has seeped into the top of the can. Look at this, it's already cracking. Let's see what happens if we touch it. Oh my gosh, it's flaky like a croissant. What the heck? That's crazy. The metal is so brittle now. And it's because the gallium slips in between the metal atoms and pushes them apart, which weakens the bonds. And once the metal loses its structure, it becomes brittle and easy to break. Let's take a look at the spoon here. It may look like the spoon is normal, but look at this. That's where we put the gallium. Now let's try to bend the spoon where we left the gallium. Oh, that's so easy. That is so easy to bend. I can snap the spoon in half. Is it because of the gallium or is it because I'm jacked? You tell me in the comments below. It's time to level up the previous balloon trick. Balloons, as we all know, are very fragile. Please, don't make any fat jokes. But we can use the principle of weight distribution to make these fragile balloons carry me. So let's try 3 balloons.
We need more. Now let's try 5. Remember, I'm about 150 pounds, and these are just regular balloons. It's almost there. Now we have 6. This time I'm gonna apply the same principle of weight distribution to me, because instead of sitting in one spot, I'm gonna lay down. I think we need 2 more, and right now it's a little unbalanced, so we're gonna have 2 rows of 4 balloons. Now we have 8 balloons. Oh, yeah, that's pretty good. I'm fully elevated. The balloons are supporting my weight. These are pretty bouncy, so let's try using it as a trampoline. Oh. We just demonstrated the principle of weight distribution in real time, because when I laid on it, the balloons didn't pop. But as soon as all my weight was concentrated in one spot, the balloons started popping. Now let's move on to the next experiment. For this next science trick, we're gonna make waterproof fire. So all we gotta do is just light our candle. Just gonna place it on top of the water so that it floats. Now, watch the magic happen. All you need is just a bigger cup and put it on top. We can start pushing the candle down. Our candle is fully submerged in the water while still being lit. Look at this, as the water submerges, the fire doesn't die out. This is happening because the air pressure is keeping the water out of the cup, making the water go around instead of inside. This is almost an optical illusion because it looks like the candle is fully submerged in water, but that's only because the glass, the water, and the cup are all clear. In the middle here, there's actually no water. It's all air. I can show you by tilting the cup and releasing some water in. You can see now part of the cup is submerged with water. But when we slowly lift up, you can see our waterproof fire is still alive. For the next trick, we're gonna be making a butane rocket. And to make a butane rocket, all you need is 2 things, a water jug and butane. Later in the video, we'll be making a much more powerful rocket. But butane rockets are very easy to make. The first step is to empty my jug. Step 2, fill it with butane. Just grab some pliers and push down on the nozzle. Now fill up the jug. Don't breathe this in. This works because when you release butane, it turns into gas. As the empty space is filled with butane gas, pressure builds up. And since gas and water don't mix, when you flip the jug upside down, the gas instantly pushes all the water out, creating a rocket-like effect. All right, here we go. 3, 2, it's go time. Woo! That was so cool. Now let's push on to the next experiment. For our next science trick, we're gonna make a giant solar death ray. Using the same concept as a magnifying glass. We all know the trick. If you put a magnifying glass in the direct sunlight and focus it just right, you can make something that burns paper. But it's not gonna make a flame. It's too slow and it's too weak. So if we wanna make a giant solar death ray, technically we just need a bigger magnifying glass. And I got one right here. This is a very dangerous weapon right here because it can literally burn through anything, including metal. And if you wanna make one of these for yourself, you can actually take apart the screens of old TVs and you'll be left with a giant convex lens, which takes a wide area of sunlight and focuses it down into a singular point. And the bigger your lens is, the more sunlight it can focus, and the hotter your death ray will burn. Be very careful where you point this, because as soon as it touches anything, it will burn. I'm gonna lift it off the ground, and as soon as it focuses into a dot, we should see fire. Oh my gosh, what the heck? That was instant. Here we go, let's go again. Oh, yo, this is so dangerous, what the heck? It instantly lights on fire. That is crazy. All right, time to put this out. Next, let's try some sparklers. If I don't focus in the right spot, I'm gonna burn everything around it. Oh my gosh, the whole thing is set on fire. I think even the moss is on fire. That's amazing. Yay, yay, science. Comment down below if it's your birthday today. Happy birthday to you. Next, let's burn something that a magnifying glass could never do. A stick. Let's see if it can break the stick. That is smoking.
Oh, it broke the stick in half. Now let's try burning something you would never be able to burn with magnifying glass. Metal. Whoa, something's smoking there. I think if I focus just right. Yo, the nail is red hot right now. It's melting through the nail. Holy crap. Yo, the nail is hot. I'm not trolling here. Look at this. Look how hot the nail is. It literally melted through the surface of the nail. With this solar death ray, we can burn through anything. Let's move on to an even crazier experiment. For our next experiment, we are gonna make a homemade rocket. And in order to make a rocket, we need rocket fuel. That is exactly why we are out here, because we are testing different types of rocket fuel to find the best one for our homemade rocket. Each one of these has a different concentration of potassium nitrate, sugar, and some even have rust powder. Our goal right now is to find out which type of fuel will burn the fastest, because that's what we need for a rocket to take off. This is test subject number 1. We can see some slight smoking. Okay, that's not bad. This one is mostly made of sugars and potassium nitrate. As you can see, the burn is a little bit slow. It's not the fastest burn right here. If our rocket was made of this fuel, I don't think it's strong enough to take off. Here we have mixture number 2. For this one, there's no rust powder, just a little bit more sugar. Oh, that's not bad. Whoa. That one's burning super fast as well. It's burning a lot faster than the first one. I would say that one is winning right now. But now we're going to try number 3, which introduces rust powder. Rust powder should help introduce more oxygen into the burn and potentially make the fuel burn faster. We'll see how it burns. Okay, here we go. Whoa, that is so fast. That was honestly like an instant release. That's gonna be our fuel right there. We just need to put this in a rocket shell and it should be able to take off. We're now ready for our rocket launch. Here is our little baby right here. The rocket was pretty simple to make, and we've just added a little bit more potassium nitrate for that extra punch. This is our rocket launch station. We slide it in and we're ready to launch. I'm gonna put eye protection on just in case. More of a smoke bomb rather than a rocket. I think the issue here is that we didn't encapsulate the ends of the rocket with clay, so it was literally just exposed rocket fuel. So the modification we'll make now is we'll cap off the ends of the rocket with clay and only drill a small hole at the bottom where it can release the pressure. I've sealed off the top and bottom of the rocket with clay, added a homemade fuse, and lastly, I've replaced the stem with plastic so it's a lot lighter. And in it goes. Oh, here it goes. I think we have a problem with our fuse here. So for times like these when nothing works, I always have a backup. This is what I call the black sheep, because what I put in here is a little questionable. We will make this work. We will figure it out. In it goes. It's go time. Oh my God. This is crazy. That's so wild, bro. That's why we call it the black sheep, because you don't know what's gonna happen. It's time for the final trick. We've gone from simple tricks to creating giant solar death rays to launching rockets, and now we're gonna go from a simple campfire to creating a giant fire tornado. All we need to make that happen is only my fans. Subscribe. First, we gotta surround the fire in a circle with these fans. Let's give that a try. All right, that should be good. After we plug them in, they should spin in a circular fashion and create a vortex to bring the flame up. Okay, let's turn these on. Add a couple pieces of wood to keep the fire going. You can kind of see the wind blowing the fire. It's getting a little higher. I think the problem is right now these fans are blowing towards each other and it's just scattering the fire. Look, the fire is blowing left and right, left and right. So we need more fans. Good thing I come prepared. We'll put the fans in a circle. All the fans are now set up. We have a perfect circle with the fire in the middle. Let's test it again. We added more fans so the wind can blow into a spiral pattern, creating a vortex instead of just blowing into each other and scattering the fire. All right, here we go. Now let's give it another try. The fans are turning on. Come on. Are we getting a vortex here? We can see the smoke kind of going up. This is a good sign. We just need to adjust the fans a little bit. So what I'm gonna do is I'm just gonna turn each fan about 15 degrees. So instead of blowing into each other, they're blowing into a slight circle, creating the vortex that we need. Oh, oh, look, 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 look. Look, it's working, it's working. It's looking pretty good. I think we just need some adjustment over here. Some of these fans are a little bit too strong. We are making good progress. I just need to move the fire pit a little bit to the left. We're now ready for our biggest fire yet. I think this will create a tornado higher than 6 feet. This goes without saying, do not try this at home. All right, here we go. Oh, it's burning. Oh yes. We ready for the fans? Here we go. Fire, tornado. Yo, that's getting so tall. All right, let's just do some micro adjustments here. Oh my gosh, this is getting so tall. Yo, that's huge. That's the biggest fire tornado I've ever seen. This is the power of science, guys. Wow.